This is the fourth problem on the worksheet that you're working through for grade 11 physics here at James M. Hill, forces in one dimension. So remember, those first 5 problems are repeated again for questions 6 through 10, except you need to use these problems as a guide to solve those. So the question reads, a box is being pulled across the floor at a constant velocity with an applied force of 184 newtons. Coefficient of kinetic friction is 0.26. So lots of information given in these 2 sentences. I'm going to start with the first piece of information. That first key piece of information is our constant velocity. That communicates the net force is 0. Applied force is given right in words. Fa is 184, and we're given the coefficient of kinetic friction, mu, right there, as 0.26. So A, what is the force of friction? So we're given applied force and we're given net force. So the easiest way to get force of friction, really the only way to get no force of friction, is to remember that the sum of the forces is the net force. So the net force is our applied force added to our force of friction. Those are the only 2 forces acting on this object. So the only 2 forces I write down. I don't write down force of gravity or normal force. Only forces acting horizontally on this object. So net force is 0, applied force is 184, plus force of friction. So rearranging, force of friction comes out to be negative 184 newtons. And then the negative communicates the direction, meaning it's in the opposite direction of motion. So that's very important. I'm going to be looking for that negative sign. So B, what is the force of gravity on the box? It doesn't seem like this is possible because the only equation we're familiar with force of gravity is mg. But there's one other key piece of information that we have to remember, is that force of gravity is also equal to the normal force. So remember, for grade 11, force of gravity equals normal force. If you're a grade 12 student watching this, this is not always true. But for the cases we're going to work with, to get used to the terminology, to get used to the problems, the normal force is going to equal the force of gravity. Knowing that, this opens up another equation possibility, and that's this one. The force of friction equals mu times the normal force. So I know what mu is, 0.26. I calculate what the force of friction is, and the normal force is the force of gravity. So I have all the information I need to calculate this. So I'm just going to summarize everything that I just said with this equation. Force of friction equals the coefficient times the force of gravity. And I can figure out now the force of gravity. Friction is 184. Coefficient is 0.26. And I'm left with finding the force of gravity. Divide both sides by 0.26. And you get 708 newtons as the force of gravity. Notice that I did not write negative 184. We use magnitudes in that equation. If you want to leave your answer as negative, of course, that's fine. It indicates the direction is downward. We're still kind of working with magnitudes with that problem, so that's okay. So I'm not going to worry about gravity being positive or negative. It's always going to be negative for us as we use our math. So if you want, just go back, stick a little negative in there, make everything happy again. Last one was the mass of the box. The mass of the box, it's nice when they ask about mass because there's only one equation that really uses that, and that's the force of gravity equals mg. Okay, so if your force of gravity is negative, remember that your acceleration of gravity is also negative. If force of gravity is positive, your acceleration is positive. So just be consistent. Since I wrote negative 708 in the end, I'll leave it as that, negative 708 newtons. Since it's acting downward, equals the mass times negative 9.81 meters per second squared, because it's acting downward as well. So those 2 negatives divide out, giving me a positive mass value of 72.2 kilograms as our mass.